Mariah for food.
Mariah for food, most importantly. Let's see.
Here's in there.
We've got scheduled next month a couple of things that I think people would be very interested in. We have the V-test. Is it the second?
V-test like Redis, or is it?
Is that V-test? Sorry. So, isn't it the second week of October?
That was the third, 17th or something?
We kind of did a, yeah. There's that one, and then there's another one that's coming out. Well, I make sure I put it on there. Yeah, yeah. So both great talks. They're both flying in. Tonight, we actually have Tom. He's actually remote, and we're glad to have him here. But I want to have just a kind of a survey here. I think this topic, if you'd asked me about stateful stuff in Kubernetes about maybe, I'd even say a year ago, I would say, not my data, right? Just because of all the things. But as we've seen with the storage interface stuff and other things that have happened, it's just amazing. So my question is, how many use storage as it normally is in Kubernetes? I mean, like actually file system, databases.
Does the test count?
Of course.
Yeah, then
Okay.
Eric does.
So let's be honest. How many of us are still kind of like, is this really something I should be doing in Kubernetes? Come on, be honest.
Chickens.
Yeah. Okay. So I think this is going to be a great talk. And I think I'm going to go kind of over some of the things that's in the history of things. I'm just going to provide some of the things that you kind of overcome, that you say now is the time, right, to do stateful persistent volume. So anyways, format we usually have, Tom, is present. I know that when we're doing remote, it's kind of hard to have questions, but we'll try to maybe say, hey, there's a question. If you want to have during this presentation or only afterwards, what do you want to do, Tom?
I have a few slides, so I can go through those. I have a little demo as well. Feel free to interrupt and stop me if there's any questions or anything like that.
Appreciate it.
The room is pretty well mic'd, so if you yell loud enough, you should be able to hear
yell. You should be able to hear.
We've done an incredible job for the mics, but we'll go till about when you're through, and then we usually like to say about 7:30, kind of it's over officially, and then the unofficial stuff happens and whatever. We'll be recorded.
It made it sound like it was like something bad.
No, what I'm trying to say is that the conversations afterwards are not usually related to this. It's just the other stuff, and it's kind of fun. As everyone's been around, right, for a long time? No, not terrible things. So, Tom, thank you for coming tonight, presenting tonight. And, I'll just turn it over to you.
Great, yeah. So thank you for having me. I really appreciate this. I think it's gonna be fun. I do wish I could be there in person, but I hope this works out. I am on Linux right now, so we'll see how well that works. My Zoom wasn't working until about 30 seconds before I logged in, so we'll kind of play it by ear, and thank you for bearing with me. I have some slides. I'm going to share my screen. I'll turn off my camera. I'll jump in. Thank you. Let's see if this loads okay.
Not seeing anything, Tom.
There's a
Says it's
slight
low.
lag.
Oh, there we go.
Yeah, I got it.
Pretty much everything I know. Give it up.
Yeah, it looks like the view's not too happy, so we might have to deal with.
Yeah.
You should be able to share it
But not presenting.
in exact.
There we go. Does that look okay?
Yes.
Okay, great. So thank you for talking with me. Some of you may know Travis. Travis actually I think was asked to speak here, but he has some important plans tonight, so he couldn't make it, and so I'm kind of filling in for him. We're actually very excited to have Travis. So Travis just joined Kasten as our site lead in Salt Lake. So obviously talk to him if you're interested in talking more about Kubernetes. I wanted to give a little brief background about myself. And actually, something that's very relevant for you guys is it seems like you're talking to the Vitesse guys at PlanetScale coming up. I worked with the founder Jiten at Dropbox together. So that was kind of one of my roles. I actually worked on the Vitesse version kind of inside Dropbox, which was a scale out MySQL cluster. It was quite large actually. Our DBA said it was kind of the 5th largest in the world, or maybe even more than that. It's hard to get an accurate count, but we managed a petabyte of raw capacity, which is pretty cool. And again, feel free to interrupt me and email me or reach out to me if you have any questions. More recently, 2.5 years ago, I was a founding engineer and now manager at Kasten, where we're trying to help people address their concerns with stateful applications inside Kubernetes. I can just kind of jump in. So I think if you're here, you're at least interested in Kubernetes. If not using it to run your production infrastructure, which I think more and more people are entrusting Kubernetes for that. What attracted me to Kubernetes was 2 big things. One was the idea that you can create a common abstraction for your infrastructure, which is really useful. And the other one was the great community around the project and ecosystem, and kind of all the operational manuals that was put into making it really robust. The cool thing about the common abstraction is it means that your code can run the same way locally in CI or in production. And you can kind of get closer to this write once, run anywhere type idea. And the good thing about the community is that it ensures that whatever abstraction is come up with is actually a good one, right? There's a lot of experience built into it, which is pretty cool. A good example that I like to point to of one of the abstractions is CSI. So CSI is short for the Container Storage Interface. And although it went GA less than a year ago, there's already a ton of example drivers that have implemented this. It standardizes the API for helping people provision, mount, and snapshot their volumes inside Kubernetes. And so we definitely see customers who are asking for it. I think a lot of the big storage providers either support it fully or are in the progress of, or have some progress towards supporting it. And the cool thing is that whether you're using storage on your laptop locally, or you have $1 million SAN, or you're running inside a public cloud like AWS and using EBS volumes, the set of APIs you use to provision and manage that storage is the same. And it's kind of up to the infrastructure providers to go and implement those APIs for you. In my opinion, and Kasten's opinion, this is still not enough to effectively manage stateful applications. And to kind of figure out what's missing, I wanted to go through a toy example. So what I asked in the meetup group what databases people were interested in. People said not MongoDB and yes to Postgres, which is great. We actually have a cool integration with Postgres, which I'm going to go through and give a demo for. But let's use it to kind of illustrate the shortcomings of, or the gaps in the current Kubernetes APIs. First off, you kind of need a set of custom tools. So whether you're using more official tools like pgdump, or you want to use kind of more bespoke tools like Wally, which helps with log archiving to object storage. You may need to combine those tools with some type of integration with Kubernetes, right? If all of our configuration is inside Kubernetes, things like secret and config maps, we may need some hooks that tie those things together. The other problem we saw people encounter, which maybe isn't specific to the gaps in Kubernetes, but is an issue, is they have a lot of infrastructure that they've written themselves around managing their databases. So things like taking backups and we see a lot of bash to do this. And really running bash in Kubernetes is not that easy. And so that we see that as a gap. Definitely one of the challenges for porting your applications into Kubernetes, especially your stateful ones. Another issue is interacting with external infrastructure. There's a category of infrastructure which I think support is kind of coming for, which includes volumes. So the issue right now is that not all storage providers have implemented CSI, and some providers have partial implementations. For example, snapshots may not be implemented. And the model may not be a perfect fit for CSI. One example is there's a lot of thought from cloud providers into what a snapshot should be. In the traditional on-premises model, this kind of maps more closely to a backup, right? I take a cloud snapshot and I can restore that anywhere, typically. But on an on-prem solution, a snapshot may mean something different. It's usually tied to a volume. If I delete the volume, maybe it cleans up my snapshot. And so I think that is not a great fit potentially for some of the CSI APIs. I do hope that the kind of get better there, and so we have a more democratized set of APIs. Finally, what we found is that actually the lifecycle of your application is tied to a lot of the Kubernetes concepts. So for example, if I have a deployment, that deployment has some number of replicas, or if I have a stateful set, that stateful set has some number of replicas. And you may have to do things like modify the deployment when you're restoring it or backing it up. And these require specific Kubernetes API calls that have to be integrated with your other tools and scripts and things. So kind of with this set of ideas in mind, we've open sourced Canister. So Canister attempts to connect the dots between Kubernetes, your storage and database operations. It includes many examples. So we were kind of very example driven. We found that a lot of people are running open source databases inside Kubernetes as kind of one of their entry points to starting using stateful applications in Kubernetes. And so the examples we have are kind of the popular open source databases. It's actually quite easy to extend though. So if we don't have an example for your favorite database, then contributions are welcome, and we're also always looking for more databases to provide examples for. Canister lets you easily create logical backups. You can take volume snapshots. You can back up data files at the file system level. We found that many customers want to use different strategies for backing up their database. For some, maybe a logical PG dump is sufficient and in fact preferable. It has some advantages, it has some disadvantages. Things like performance may be an issue, but it's very portable. If I have a logical database backup, I can restore that kind of, in any cloud provider. If I have a volume snapshot, maybe that might be much more efficient, but it may not be, it's not restorable in, for example, between different cloud providers or between cloud providers and on-prem. And so Canister really kind of connects all these dots, and it makes it easy for you to choose the approach that best fits whatever strategy you want. And of course, this all happens through a Kubernetes native API. I can't quite see hands, but we use something called CRDs. CRDs is short for Custom Resource Definition, which is kind of the canonical Kubernetes API extension. Just like Kubernetes, Canister uses declarative API objects. So everything on the right is an API object. We have, there's 3 in Canister, and I'll go through what those are. And just like many Kubernetes projects, Canister has a controller which runs inside your Kubernetes cluster, and that responds to the APIs we create. So the 3, I'll go through kind of quickly an overview of the 3 APIs, and then I'll dig into an example of how to use these APIs to back up and restore your databases and your stateful applications. So the action sets are essentially how we trigger some work in the system. You could argue that it maybe goes against some of the truly declarative paradigms, right? I'm actually using an object to perform an action, not to express a desired state. We kind of argue that you're expressing a desired state of having run the action. Maybe we're cheating there, but you can decide. Blueprints contain how to run that action. So typically what we see is you'll have one blueprint per application type, and that blueprint will contain all of the operations you need to run on there. And the other final API object are profiles. And profiles are essentially just configuration. Typically what's in there is a reference to secrets that contain credentials for things like object storage or for taking volume snapshots. I'm not going to talk too much about profiles, but they're very powerful because you may want to use different credentials at different times. So let's kind of jump through an example here. So let's say that I have Postgres running and I have my infrastructure set up for object storage. If you notice, I have a little robot next to Postgres, and this robot is representative of Wally, which is a tool which helps ship Postgres logs. So we can kind of take continuous backups of Postgres. And of course, Canister has hooks for all these. From the Canister side, what I need to install is the controller and a blueprint. We try to make this very easy, and you can check out the documentation to see how to do that. When I want to back up my database, I create an action set. The action set describes the blueprint I want to use, the app I want to back up, in this case Postgres, and kind of the artifacts I want to create. So in this case, the object store artifacts. Once that object is created, the controller will pick it up, go look up in the blueprint how to perform that action. And it will then go perform some type of work. Most work we perform is usually kind of spinning up a pod and then doing some type of operation, whether that's doing a stream, like a logical dump of the database and pushing it to S3. We also have some primitives which help you exec inside existing containers, similar to kubeexec. In the Postgres example we actually do use kubeexec. We run these commands directly inside the same container as Postgres is running. The reason we do this is because we want to interact with Wally, basically. And Wally, for continuous archiving, has a limitation that it has to run with, in the same instance as the database. So once we run this command, we'll create a full backup and push it to object storage. And once the command completes, Wally has been configured to continuously push to object storage. And then we can use the same methodology to do a restore as well. So we create an action set, and it'll go through the same workflow, but it'll modify your app and restore data from object store. Any kind of questions on that?
Tom, do you have action sets? Would action sets be used for like scaling databases too, like creating shards potentially, or?
That's a good question. When you first said scaling, I thought you were talking about the number of replicas.
Or that too.
Yeah, I think, so we don't have examples for that. What we've found is that people need to kind of develop their own scripts to do those specific, very data intensive operations. We do try to make it easy to run things. So I'm gonna go through a little example, a snippet of a blueprint. And you could potentially embed whatever commands you need to do your scaling inside that blueprint. But I think most of the operations that we consider are kind of backup and restore. That may be a primitive that you use in your sharding scheme. And I think you have to, that's very custom, right? You have to figure out what's the best approach for your infrastructure. But thank you, great question. And that's a great thing to talk to the Vitesse guys about. They think about sharding quite a bit. So let's look at the content of an action set. If you're familiar with Kubernetes APIs, they typically have the same kind of boilerplate. In this case, we have an API group and version. Objects have a type, so in this case, it's action set, and they have some metadata associated with them. I've abbreviated this, but there ends up being a lot of metadata. The actual different part of an action set is in the spec. So a spec has a list of actions. You can perform a chain of actions. In this case, we're going to perform one, which is a backup. The backup is actually the action we look up in the blueprint, which I'll show you in a second. We name the blueprint we're using, and we name the object. There's also a bunch of configuration we can pass in here, but I've omitted that for brevity. But basically, this is kind of like binding all the different components you need to run the action, and then the controller will go perform that. So if we look at a blueprint is actually a little more complex, and they're typically larger. This blueprint snippet is much abbreviated. In fact, if you look at the one from inside the Canister repo, because we're dealing with Wally and setting up log archiving, there's a lot of kind of work we have to do to make sure we, for every base backup, there's a single stream of data we're pushing. But in this example, I'm just invoking pg dump. So again, this has the same type of metadata as an action set or any other type of Kubernetes object. In this case, there's a map of actions, and one of them is called backup. So the backup we saw earlier in an action set is what we look up in here. From there, the backup action has several phases. One of the phases here is we're going to exec into a specific pod and then run this command.
Coupons and hello to cashback. And hello to cashback.
I thought that was a question. And yeah, so I don't know if you can get cash back from running a blueprint, but
See, they're good.
Too good. So I'm seeing there's the pod and the command looks like they're being processed as some sort of Go template. Is that right?
that's right, actually, yeah. So the reason we use templates here is because we want to take values from the parameters in the action set. So we do a lot of work to provide useful values inside the template to make it easy to kind of write very customized blueprints. Kind of one idea we have is that you want to write one blueprint for one category of app. So if I have 10 developers who each need their own instance of Postgres, they shouldn't have to write their own blueprint. We should have one kind of standardized blueprint, and then all the parameterization you need should be available through the Go templating. But yeah, that's a great insight. In fact, I'm pretty happy with that approach. The one downside that we have is that if you want to write a Helm chart to deploy these things, then double templating has caused us a lot of issues. And Go templating is also a little bit quirky. I know some people in the community have moved away from that. You know, so Helm is actually an example, right? They've moved to they're talking about supporting other templating engines as well, especially for Helm 3. But yeah, great question, great insight, I should say. So with that, I'm going to jump into a little demo. One of our engineers recorded this, and it's the first time I'm showing it, so we can do it. I like to record these because they actually go, sometimes like taking restore, scale up, scale down, using real data actually takes some time. So is this okay? I know it's a little bit small. Can everyone kind of see this?
Great. Yeah, looks good.
Okay, great. So I'll describe what we have here. In the left panel, we've just our general command line that we're going to run our commands on. In this case, we've logged into a Postgres database, and we're going to inject some data. On the right, we have two panes. The top pane is actually just handling the Canister log, so you can kind of see the update as actions complete. And in the bottom right pane, we're just tailing all the pods inside the namespace. This will let us see the pods that Canister is creating, as well as the status of Postgres as we perform operations. Play. We'll just inject data. I sped this up, but we'll see if it's fast enough. Creating test database, and in the test database, I'm injecting this person. So Paul's in the database now. Okay. Let's take a look at the profiles I have access to. I mentioned that the APIs are declarative. Just like Kubernetes, we also have this imperative style tool called CanCuddle, and CanCuddle makes it easy to run imperative commands. So I can easily create an action set with command line flags, but this could just as easily have been run using kubectl as well. There's actually a lot of parameters here, mostly just specifying kind of the object we're working on, the blueprint, the profile, and the action. So kind of the same content you saw in the action set. I'm also passing a secret. We allow users to specify a secret, then we go collect them. And you have to be careful that it matches your security model. So you have to use RBAC to limit permissions, so you don't leak those secrets. So you're going to use the correct profile here. Okay, cool. So we ran that. I created my action set. If you look on the right side, you can see that the Canister log is showing that the backup action is pending. I'm doing my first phase, which is my base backup. So I'm doing a full dump of the database. Continuing on. Now I'm going to look at actually the backup just completed. I'm going to describe that backup. Something that's important for any operational tool is monitoring. In this case, we use Kubernetes events to help give the status update of what's going on. If there's any failures, they kind of show up here as well as in the log. In this case, it completed successfully, so we see that it's done, and that's updated in the action set as well as the blueprint. So you can kind of get this hailing log of all the actions going on. So let's check out what happened in the object store. When I took my base backup, I created a large tar. So if you look at, and once I've completed that base backup, Wally will start shipping the wall files as well. So this S3 bucket, if you look at kind of the second entry, that has the first part of the base backup as well as some metadata. And then if you look at the kind of second half where we have the wall files, each of those were backed up as they were created. Postgres has a great hook called log archiving, which is how Wally pushes its wall files to object store. Okay, moving on. So let's log back into Postgres. We're going to nuke our database. And now we're going to try restore. So the other great thing about these action sets is that they're updated with the artifacts we've created. And what Cancuttle helps you do is actually chain action sets. So if I've created a backup action set and it has my list of artifacts, I can then go create a restore action set from that backup using Cancuttle. So this is how I'm going to chain them. This will create a new action set with the action restore from that backup. This operation is actually much more intense. It is actually scaling down the database, creating a new pod. So if you look in the lower right, we have this prepared data pod, which is going to mount the same volume and then pull down the data and then use Postgres to actually restore all the wall files on top of that data. So part of the issue here is that you have to coordinate the life cycle of the app itself with your data. You can't, for example, do this on a running pod. Otherwise, Postgres will behave badly. It will kill the pod, and you'll lose your connection. And so part of this is the management that Canister provides. So it actually takes a while to do that scale up and scale down. It looks like it took a minute, and so I skipped ahead. We can look at right now we're executing the restore, and it looks like it's going to complete pretty soon. There we go. And so the restore completed. And we can go check in Postgres and see, hopefully our friend Paul has been restored. There he is. And so that's all I have for the demo. Were there any questions on what I just showed and Canister specifically?
Yeah, the action, that acts more like when you create the action that is saying do the work. It's not the thing that defines it, right? So
that's right, yeah.
Okay. So theoretically, you would have actions and you could go and check and like list all the actions that have run in the past and see the exit status essentially.
That's right, yeah. And what kind of, there's different ways you can model this. What we've typically seen is that people will delete completed ones pretty quickly. But for example, like in our tests and things, we leave anything that fails around so we can go kind of investigate and debug what happened. From Canister, actually, the action set also contains any output artifacts. So it will contain the reference to the object store path of the artifacts it created. And so if you do want to restore something, you still need that action set.
Okay.
Tom, how generic is the action set? Meaning, could you create other workflows besides that which is being done here? I mean, could you CI/CD type stuff or weird other things? Can you do other things with your action sets?
Absolutely, yeah. I mean, my CEO and I gave a talk at KubeCon last year on how to integrate Canister in your CI/CD pipeline. The central premise was that you want to maybe use some subset or some masked production data in your CI/CD pipeline. And the basis for that was through Canister. I think the primitives that we still look at are typically backup and restore. In theory, you could add any type of primitive you wanted, but all the hooks and helper functions we have are really targeted towards interacting with your storage primitives. But there's nothing stopping you from, for example, encapsulating arbitrary database commands in there as well.
Thank you.
Yeah, thanks for the question.
For the object backend, what other options do I have other than Amazon? We encounter host systems on customer networks. Where else can I go with it?
Great question. So I said S3, but actually what I meant was S3 compliant. You can use any object store, especially ones that support the S3 protocol. We also have support through a tool called Stow, which lets us kind of multiplex between different object store providers. The big ones are obviously Minio, Azure, Blob, and GCS, Google Cloud Storage. And we support, GCS is actually interesting because it has an S3 compatibility mode, but you can also use the same, use the native API as well.
Thank you.
Okay, great. Unless there's more questions, feel free to email me or Travis any questions you have. I'm going to go back to the very first slide because it has my email on there. It also looks like
on the Ford Utah Slack, so you should join that if you want to message him.
Oh, that'd be great, actually. Yeah, I'll do that. We're a big Slack fan. Canister itself has a Slack channel, and we're very responsive on GitHub too if you have questions. Looks like my Office 360 is quite slow right now. So, yeah, thank you so much for having me. I really appreciate your time. I will say we're hiring aggressively in Salt Lake, so feel free to reach out to us.
Hiring remote?
We're hiring in Salt Lake.
Like they have an office downtown that they just opened.
Yes. For now, it's actually a WeWork, but we're looking at offices as well.
So quick question, Tom, on the CSI, are you finding that, it's stabilized quite a bit in 115. Do you see it changing more? Are you active in that SIG or are you influential in that SIG?
Yeah, great question. I think the upcoming changes I see are around volume resizing, which I think is a useful primitive. The tension I see is something I alluded to a little bit, which was around the difference between snapshots for on-prem systems like SANS versus cloud providers. I think I don't know how that's going to be resolved. It's kind of time will tell. I don't think there's going to be many upcoming changes in the next 6 months. The things that we're tracking are around. We actually do want better support for these on-prem type storage systems. So things like Ceph, for example. I think we actually are contributing to some of the Ceph work, and specifically the lifecycle of some secrets. So we have our own custom implementation of taking snapshots of Ceph, and in order to kind of push that implementation into a CSI driver, the API needed some tweaks. So one of our engineers is actually working on that. And I actually recently pushed a minor commit around some build process stuff in CSI as well. But yeah, I think for the most part, for the immediate future, it's been stabilized, but there will be this kind of ongoing tension between cloud provider storage and on-prem storage. Does that answer your question? Are you, can I ask your interest in CSI?
No, yeah, that sounds good. The follow-up kind of question is that what are the troubles that you've seen in the persistent state set world? And do you think then this approach with CSI is going to fix those issues or those concerns?
I think the big issues I've seen are really around how to manage things concerning the full stack. So when you look at a database, storage is a really important component, but to say that having really strong volume snapshotting primitives would mean that wouldn't mean that you're going to have a reliable database stack, right? I think there's a lot of operational work that has to go on top of that. And you can also talk to the Vitesse guys about this, but what I view is that you still need a lot more on top of it. And I think Kubernetes and the ecosystem are building the correct primitives that you need. But in order to run your infrastructure, you're still going to have a lot of the same issues you faced in VMs and bare metal, where managing your database and performing these operations is still going to be very difficult and require a lot of kind of legwork, and potentially using vendors to help ease some of that pain. So our company, for example, we have a paid product which tries to do just that. And it uses Canister for all these open source type integrations with CSI and everything else. But it kind of connects the dots between those operations and then your enterprise needs, things like authentication, and that kind of category of work.
And are you thinking about having like a catalog or registry of blueprints and action sets and such to share in the community?
Absolutely, yeah. I mean, every blueprint we write, we open source. We do have some customers who we've helped write their own blueprints that are specific to their infrastructure that they have not open source, but we're trying to either encourage them to open source it or write our own flavor and open source that. That's maybe less specific to their infrastructure. In terms of a catalog, we actually were using the approach that we were taking maybe 6 months ago was we would take an upstream Helm chart and then add a blueprint and then re-release that chart. What we found though is that people, even if they're deploying Helm charts, they're actually either modifying them or just in many cases writing their own deployments and config maps and things. And so for us, it seems to be lower friction to actually just release the blueprints directly. And that catalog is actually just in the examples directory in the Canister repo. So we're kind of in the process of migrating from this Helm-only approach to this approach where we work with the upstream Helm charts, but we are just releasing the blueprint inside the repo.
We have people online, don't we?
Yeah, we do have 7 people. If there's anybody online that has a question. Wait, that's
Thanks, Tom.
Cool. Thank you so much. I appreciate your time and have a great evening.
All right, so interesting stuff. So after all this, how many are going to go to use stateful sets and databases in Kubernetes now? Huh? A few more? Huh? Yep. I think there's some interesting stuff.
Stateful sets are important, by the way, even if you don't need the copies. So if you don't primarily the automatic kind of pairing of zones with deployments, that hit me hard recently. You just make a deployment and have some, you're like, oh, I'm going to make a persistent volume and it'll be fine. No, because oftentimes the deployment has no concept of where your volumes are. So,
JC or whatever.
Yeah, and so you'll get really weird things where things won't just work because the volume's in one place and the deployment made the pod in another and it doesn't actually care.
I actually had the same problem. I was doing a NAT streaming, right, and persisting on the file system rather than the database. And I was trying to do it through the operator and some other things, and it kind of worked. But it was always worrying about waiting for the EBS volume to come online and that AZ and all that type of stuff. Then I switch it over to a stateful set. And two, let's see, one, you get nice names, and you can guarantee those and do some nice, interesting things. And then the second one, it does exactly what you're talking about.
It pairs your.
It pairs it straight up to the AZ, and it's nice. It made it actually work.
So even if you're only going to run one, and you think, well, I'm not going to use a stateful set, they're almost identical to deployments, and you get some zone value.
In the early days, there were pets. They were called them pets.
I remember, yeah.
And they were a little interesting at the time. But so how many are actually using stateful sets around?
People know what one is.
Yeah. How many know? I'm sorry, I shouldn't. How many know what a stateful set is?
And people know what a deployment is. No?
Any of the things.
Oh, okay.
One of the things.
Go ahead.
So deployments are the kind of one of the primary way in Kubernetes that they first came up with for declaring, I want to run an application, I want some number of copies of this application to run, and here's the template for what it looks like. Because, the alternative to that is making pods with, copy pasting and changing a name to try to keep 10 of a certain exact thing running. And those were great for stateless things. The problem is they had no concept of persistent storage. They had no idea how to provision persistent storage, how to bring anything up in an ordered way. So if you
DNS, IP, all
right, yeah, if you change a deployment, it'll just scale some in and some out, and it doesn't really care. And that didn't quite work for databases where you needed guaranteed order, and you need to say, for every copy of this you make a new volume in the cloud and tie it in. And so stateful sets are a similar thing. You say, I want N copies of this running. I want their storage to look like this every time you make one, and then here's what the resource looks like.
Sorry, going for those. So they're persistent volume claims, and that's kind of how you describe your storage and then the actual instances. What's nice also about the stateful set is that kind of it does it for you through the persistent volume claim. And so what's nice about it is you can just specify the storage class that you want to use, meaning like it's a fast SSD or whatever size or whatever you need to do. But then what's nice about the stateful set is you can just do it right there, and it just does all the PVC and PV for you. And
so I think to Tom's point though, on-prem definitely has it's a crapshoot. Right?
Yeah.
And so making your on-prem a little more Kubernetes-like via stuff like this is, I think, where the value add is. I deal with on-prem a lot, and it's, well, those guys decided not to do this, so now I have to bash script something together that doesn't quite fit normal paradigm of a lot of things.
So it doesn't look like their stuff handled any of the volume creation, it's still 100% dependent on that for something else.
It's not volume creation. It's a way for you to abstract local infrastructure in a Kubernetes fashion, right? So you can then, just deploy this action, and now all of a sudden you're getting a series of things done that may not look or feel when you look inside like it's Kubernetes, but you can interact with it, you can observe it, you can monitor it.
It's like the cloud provider, that you have with Kubernetes clusters. Now you kind of have a on-prem provider as well, so that you can have the different operations that need to be done.
It kind of makes, because if you've ever used a managed Amazon, like an Amazon RDS, you go click and you say, make a snapshot, and it shows you, here's a snapshot we're making, and you can go click and restore it. And there's no clicking, but it's the same kind of idea, like make me a snapshot now, and it'll track it. And so I can definitely see that.
So how many still have on-prem clusters for various reasons? Yeah. And this has always been still an issue, is the storage. And
if you have money, you can use Pure Storage, and they have a Kubernetes.
Well, and that's what I'm going to say. If you have money,
and it feels like a cloud provider.
Not really though, because I have that one. Yeah.
Too, but
you might want to talk about what the issues you're finding out.
I'm not trying to do anything magic, just network attached storage.
You tried any hyperconverged stuff? No? I can never do a demo because we just deleted our clusters, and you can't really hyperconverge storage onto nodes you plan on deleting. But it always seemed like a really cool idea for on-prem, like run this other component and leverage the storage in all your nodes like they're a cloud without them being a dedicated device.
Does Portworx, does that have an on-prem too?
That's hyperconverged, so it doesn't matter. It's just, if you have a Kubernetes cluster,
It'll take care of it.
same thing with Rook.
Yeah,
Rook is fully open source, so.
Those are the Rook I've been trying to tracking for a while, and it's kind of come up.
Rook is just Ceph with some stuff on top.
Yeah, how is it doing? How's it working for you? Is it still mature, or is it matured a lot more?
It's mature for what? So we build a tool within Teradata to deploy Kubernetes on cloud and bare metal platforms, right? Same tool does it. And the on-prem solutions that we ship, we use Rook to take all the storage that's on the current set of nodes and use it. Display it.
It seems to be.
Yeah, and it seems to be okay. The problem is that our application teams don't really understand, like, containers, Kubernetes.
So it's other things.
So they're using stateful sets, and they're using a common mounted volume to pass messages between two namespaces.
So you don't need a volume.
We'll find a way.
Consistent
We'll
volume.
find a way.
It just blows my mind. Blows my mind.
I think early on too with the pet sets and how they were described and the stateful sets, I've always thought also it was to provide a full stack too. It wasn't, I think most of the time you see it now is related to storage. And I think there's some great examples of it. I don't want it to just be limited to that because you could still do a lot of interesting things in which, well, let me rephrase that. I think operators have kind of taken over that world a little bit.
Maybe, but it's kind of like, it's a lot like just, even if you didn't do storage, it's like a deployment with more deployment guarantees, right? So you can do, the fact that it's ordered, if you need to cycle all the things, it brings them up and down in a known order. The fact that you can do a headless service with it and get the same host names every single time.
But do you think, is that a fair statement that maybe operators may take over that realm of operations and all?
Well, you're already seeing some of it, like Argo, what's the new Argo thing? Argo works. Argo deploys are like a lot of people saying, well, we like what deployments do, we like what stateful sets do, but we want something that's not either of those. And so, yeah, it's an operator, but it's an operator that is more or less just cloning something with some changes, right? Like Argo deploys will let you generify your blue-greens and your canary deployments, but they more or less look like regular deployments.
One of the problems we've had with stateful sets and the way app teams have deployed them is that we have one application team that has decided that since in the past on regular on-prem hardware, they had all the resources on the node, that their stateful sets should get the same thing. So node dies, and they have nowhere to go because their pods and their containers in those pods are so big and there are so many, there's no room for them to go. So one machine goes down and the whole cluster is not working.
Yeah.
So we're trying to push them to go to daemon sets simply because they back themselves into a corner in the way that they're currently thinking.
Anyways, sorry, go ahead.
One thing we've learned doing lots of stateful sets is I would never do more than one replica on a stateful set because it ends up, what used to be, right now you're treating it like a pet again, and like you have three replicas of a cluster, and -0 goes down, you have no way to like just totally shoot it and bring it back up without scaling down to 0. And so it's been, we accidentally fell into it with some things because we have, we have a master that usually runs on a normal pod, another one that runs on a preemptible VM. And those are just so much easier to manage. So that's my takeaway is I would just take over the naming. Everything can be -0. Stateful sets are cool, but.
So wait a second, I'm not sure I understand because, I mean, for instance, I've had that stream, right, with the stateful set. I can kill 2 of them and then they'll come right back up. using the same, order, meaning the same names. Saying that if you had something that's conditional upon order, you'd have to bring it all down and then bring it back up.
It just gets harder. Like you can't just eliminate -0 and it's PVC and all the things associated with it.
Well, I guess that's why it's.
That's kind of its point though, right? Like,
Yeah.
just want it for the volume stuff, right? That's the point, is you don't want the rest.
Yeah, it's
You don't really want
volume.
the rest, you just want the volume matching.
Right. And I want consistent DNS still, and,
Right.
but there's no benefit to having it scale up and down.
Gotcha.
Like, I'm already managing with pod disruption budgets, how many allowed to be up or down at the same time. So like, the stateful set rollout mechanisms aren't, well, anyway. It's just so nice to have, here's my stateful set with my one pod, and I can kill it, I can.
Really, I never thought about it that way.
There's nothing wrong with that either.
Yeah, it's kind of cool. Well, I think that's it. Let's stick around and mingle. Again, thank you, Reeve, for the food, the place, and just the good company we keep here. So anyways, thanks for coming.